Okay, now we're going to take a look at some applications of differential equations. And we're given an example here. It says a certain radioactive isotope decays at a rate of 3% per year, or 3% per 400 years rather. If T represents time in years and Y represents the amount of the isotope left, use the condition that Y equals 0.97 Y naught to find the value of K in the equation Y equal Y naught e to the KT. So we're going to write down everything that we know. All right. Well, I know for starters that Y equals 0.97 Y naught. Okay. And I know the other equation that's given is Y equal Y naught e to the KT. Okay. And I know that T happens to equal 400 years. So what I'm going to do is I'm going to actually equate these two statements. Since they are both equal to Y, I can then in effect say that 0.97 Y naught equals Y naught e to the KT, where T is 400 years. Okay, so it looks something like that. Okay, so the next thing I notice is that both of these have a Y naught that can be divided out. So we can eliminate that in both cases. So I can then say, well, 0.97 equals e to the 400k, if you will, because that's what it ends up working out to. And now my job for this problem is to solve for the value k, because that's the whole idea of this. So what we're going to do is we're going to try to, in effect, bring down this power k. What we need to do is take the natural log, and the reason for taking the natural log is because we're dealing with the base e, the natural base. And so in doing so, we actually eliminate the base e from the right-hand side. And we end up with something actually really simple, which is the natural log of 0.97 equals 400k. So if I wanted to solve for k, all I'd need to do now is divide both sides by 400. So I have my k in effect. My k happens to be the natural log of 0.97 divided by 400. And if you wanted kind of an exact answer, I suppose that's what it would be. But if we take an approximation, we get a negative value, of course, and it's going to be something that looks a lot like this if you work it out on your calculator. Okay, so you may need to be very careful with rounding and things like that, but otherwise this should work when you're solving something like this. As always, I hope this video was helpful, and remember, like and subscribe.